Okay, welcome to this 6P. So today was all about recording, and so you've explored using 3 different types of recording devices or microphones. The H4n Zoom, the Sennheiser condenser mic, and the Shure, I think it's an SM58 dynamic mic. And what are the differences then? Some of you have come back and have told us that the difference is in the sensitivity of the microphone or in the quality of it. And these are all valid observations. But let's take a closer look at all of this, all right? These are the 2 microphones. The dynamic mic is the Shure SM58. This kind of looks like a regular handheld mic. But we've got the condenser mic, which looks like a real long stick. And this is really important for us to know because it's designed this way for a reason, all right? And we're going to explore some of the differences and how this works. But this makes it more sensitive to the sounds. And let's take a look at some of the advantages and disadvantages of the dynamic and condenser mics. Do keep in mind that there are other types of mics, but we're not going to be studying these simply because you're not going to really need to use them that much. And so there's no point in us taking a look at these mics yet. These are the 2 most common mics. It's the 2 that you're going to need to use the most often. All right, so let's take a look. If you look at the chart here, the condenser mic has a few advantages. It's highly sensitive. That means it picks up sounds from a distance. So this is good for distant miking, right? It's highly sensitive, means that it also has a better frequency and transient response. That means it picks up a broader range in the frequencies. Okay, good lows all the way to the highs. Okay, so fairly broad, and it picks up at a distance. Very sensitive. But that also means that you have to manage your sound because a sensitive mic picks up a lot of ambient and background noise. Right? Now, being so sensitive is also a disadvantage because anytime anything is built to be super sensitive, it also means it's built with fragile parts. Sensitive parts are fragile parts. And that also means fragile parts become costly. Right? So do be aware of that. A condenser mic is fragile, much more fragile than a dynamic mic, and it's much more costly. Even the cheapest ones cost a few $100s. Now, the other thing is because it's so sensitive and because it has such a wonderful frequency response, it also requires more power. More than just the power that comes through the cable. You actually have to pump 48 volts or 24 volts into it in phantom power. And so you need to have that supplied. Some condenser mics actually come with a power pack adapter. So you can pop in 1 or 2 AA batteries and they'll power that for you. Whatever it is, condenser mics require extra power, whether it's phantom power or battery power. Okay, so pluses and minuses. The dynamic mic. Now let's take a look at that. This sounds really good. It's rugged, it's resistant to moisture, and it doesn't need any extra power. It can do it all on its own. Right. It's very good for that, but it's also the trade-off. Because it's more rugged, and it's more resistant to moisture, it's also less sensitive. The parts are not there, the sensitive parts. So, and because it's not as sensitive, yeah, it doesn't need the power. Of course, not being as sensitive means that it's a little bit less accurate. It's not very good for distant miking. It's only going to have a range of about 1 meter or so. And it has a very limited frequency response. That means that the range of frequencies is not going to be as broad as a condenser mic. Okay? So there's a trade-off. You have to know what kind of microphone you need in what situation. What is your recording situation, and what kind of microphone does that demand? Okay? It's a trade-off. So you have to kind of know. Now, you've heard me mention frequency response. So let's take a look at that. It must be very important if I've mentioned it so many times in just a few slides. And indeed it is. Because frequency response dictates how we judge our microphones for a particular use. All right? And it can help us in deciding which microphones we need to buy or rent for a particular project. It also helps us frequency response in speakers, okay? Sound output. So it's input, output, right? And so if you've never seen something like this, you don't know about it, but you love your music, you better pay attention to this, because this will help you choose the best headphones, the best speakers for your system, for your car, whatever the case may be. And for your projects, knowing what kind of microphone and the characteristics that it has and how to read this will help you choose the right mic for the right situation. Let's take a look at the graphs here. For every frequency response graph, there are two key pieces of information. And first is the vertical measurement, okay? And the vertical measurement is decibels, right? In this case, it measures the decibels in increments of 5 decibels. And this is important because sometimes microphone graphs are use more increments or less increments. Maybe increments of 10 or 20 rather than 5 or 10. Right? This makes the graph look different. It can be misleading. Okay, so decibels is the vertical. The horizontal axis gives us the hertz, okay, the actual frequency. And as you know, human hearing is 20 hertz to 20,000 hertz or 20 kilohertz. Now, typically our microphones, we want it to fall within that, but there might be special occasions when we need something extra. I have seen microphones advertised that will record as low as 5 hertz and as high as 35,000 hertz. And why would we need something like that? We don't hear that high or that low. Well, yeah, we don't, but other animals do. So we might want to capture that sound. We might want to play it back. So, yeah, that's one of the reasons. In any case, we'll take a look. So this is for the Shure SM58. This is the one you use today. And if we look at it, it really starts to pick up at around 50 hertz. And probably it's about 8 dB, minus 8 dB, I should say. Right? That's where it starts to pick it up. So it's there, but not quite there. All right? And it moves up and really starts to pick up at about 100 hertz. Okay? And at 100 hertz to about 2,000 hertz, it's fairly static. And all of a sudden it peaks. The sweet spot for this particular mic seems to be from 2,000 hertz to about 10,000. All right, that's a sweet spot for this mic. It looks like it's the most sensitive there. So it's the most sensitive for the upper mid frequency range to the high frequency range. Okay? And this is important for us because now we know that this is the best spot or this best range for us to be recording. Fortunately for us, most human voices fall between about 1,000 to about 7,000 hertz. Okay? Some of them fall below that, some fall above it, but for the general voice that we may want, this should be more than sufficient. Okay? Now let's take a look at this one. This is a different chart. Wow. It's got 2 lines. What's that all about? Well, the Shure SM58 is a dynamic mic. And that means it's omnidirectional, meaning it captures sound all around. And it's fairly even. It captures fairly evenly all around. It's not too radical in its frequencies. Okay? But this one is likely to be a condenser mic, and I'll tell you why. First of all, we know that condenser mics have a very, very broad frequency. Well, this dynamic mic is from 50 hertz effectively to maybe about 15,000 hertz. When we take a look at this, it picks it up at about 25 hertz and goes all the way up to 20,000 hertz. That's much wider. It's a very broad thing. So the frequency response is very, very wide. Okay? It's sensitive. It picks up 25 hertz at maybe about minus 2 dB. And that's very good. And it maintains that all the way till maybe about, oh, it looks like about 1600 hertz. And then it starts to climb up. And it sweet spot is from about 1500 all the way, I would say, to about 20,000, maybe 18,000 hertz. That's a big sweet spot as well. Much broader range there as opposed to the dynamic mic. But the other thing is polar patterns. Condenser mic has a different polar pattern. And so we can measure the response from the front, which also might be different than from the side or from behind. Okay? So that's probably why it has that. Speaking of polar patterns, let's move on. So these are not funny looking lollipops. These are polar patterns. The patterns that microphones use to pick up sound. This is a typical dynamic mic, is omnidirectional. It picks up sound all around it. Front, back, side, everywhere. It's a big circle all around it. The cardioid, however, doesn't. The cardioid picks up primarily in front. Okay? A little bit on the back side, but not directly behind the mic. The supercardioid and its relative, the hypercardioid, pick up sound primarily in the front, but there is a little part in the back where it'll also pick up sound behind the mic. Right? So we have to be aware of that. And then we have the bidirectional, also known as a figure of 8, because it kind of looks like the number 8. So this picks up on either side, but nothing in the middle. And then, of course, we have a hemispherical one. And this will pick up, well, basically a semicircle, okay, a hemisphere. Let's take a look at some other graphics here that maybe better illustrate it. So as we can see, this looks like a globe around it. It picks up everything around it. And this is a typical dynamic mic kind of a thing. But it's very limited in its range. All right? So we have to be aware of that it might pick up all around, but it's very, very limited in its range. Whereas a cardioid will pick up either longer or wider. Okay? It's sensitive. And so it's got a much different polar pattern and sensitivity. So it might be more sensitive on the sides, not as sensitive in the front, or vice versa. We have to be aware of that. Let's take a look at some other ones that you can see. Again, I showed you the cardioid and the omnidirectional, but here is the supercardioid, and you can see from this one, there's a bulb in the front and a bulb in the back. So it actually picks up sound from behind. And this is important because we need to know this if we're going to be miking something. If we don't want any sound to be picked up from behind it, we have to use something like a cardioid instead of a hyper or supercardioid. But if we want the sound to be picked up, for example, maybe we're recording a brass band, and so we want to have some of the sound from in front of the person picked up. We want a little bit of the audience sound. Then we would use this. This is a figure of 8 or a bidirectional. Basically, if it's a microphone that looks like this, with a sensitive area here and a sensitive area here, that's where you'll pick up. And the side, almost nothing. It'd be an interesting experiment to bring one in and demo it for you. All right, so let's take a look at recording quality now. The recording quality is comprised of a few things. And so let's take a look. First of all, we're talking about it has to be clear. So that means you have to know what kind of mic you're going to use for what situation. If you're going to use vocals, and this seems to be the most common at the moment, the vocals need to be clear. It needs to be legible, auditorily legible. There should be no distortion or any clipping. Okay? You should set your input level to peak at about -6 dB. -6? Isn't that quiet? You would think so, but keep in mind, 0 dB is the theoretical maximum. So -6 is actually just below the theoretical maximum. And this is necessary so we give ourselves some what we'll call headroom, so we don't clip. In fact, let me talk about clipping for a moment. Let's take a look over here. If we've got a graph here, this is how our waves look like. In fact, let me re-illustrate it for you here. And what we have is something that looks like this. If we got a band, and normally when we record, our waves kind of go up and down like this within here, and it might even go like that. Okay? And that's typical. But if we have clipped, and this is where the term clipping comes from, it really means that it's going above that theoretical maximum before it comes back down. And now this part has been cut or clipped. Okay? We've lost this audio. This area of audio is beyond what was the instrument was capable of capturing. And because of that, it's clipped, the device just cut it off. And so we get that buzz sound because there's no top there. Okay? So that's what clipping is. And it's very important to understand that, because you can never get that audio back. Once it's gone, it's gone. It's in the moment, and if you fail to capture it, that's it. So it's always better to be a little bit softer, because we can boost the sound and augment it, but we can never get something back that's never been recorded to begin with. Right? So clipping actually just cuts off that audio, and we can't record. There's nothing there. All right. Noise. If you set your input level too high, it makes your mic very sensitive. And this is important to note with condenser mics. If we're trying to control or manage our ambient and background noise and how much is captured, we want to manage our input levels. All right? So we might not be aware of certain sounds even, such as the aircon or a fan or a hum of something, an electrical device, because our brains tune it out. But the mic will pick it up, and you will hear it then. So we need to manage that. All right? So we want to make sure that we don't have it too sensitive. Proximity, microphone proximity, how close it's placed to your subject is also important. If you're using a condenser mic versus a dynamic mic, how close it goes is very important. But even with a dynamic mic, we're tempted sometimes to bring that microphone very close to us. And we don't want to do that, simply because if we do that, we're going to pick up something called vocal sibilance, right? Which means that the sounds we make as we speak can be captured. Hisses and pops and clicks. And this typically happens with what are known as the plosive consonants, or the plosive sounds. And plosives are sounds like P's, B's, T's, even things like S's and TH, S and Th, where sound and air exit out of your mouth with force. It can hit the microphone, and it can cause some hissing sounds or some popping sounds. If you don't have a pop filter there or a foam guard, you've made your job very, very difficult. Okay? So be aware of that and keep it a little bit distant, especially if you don't have a pop guard, pop filter, or a foam guard. Keep the mic a little bit distant so you don't get that hissing and popping and clicking sounds. In short, though, a clear recording needs to be clear, and it needs to be well balanced. All right? So make sure it's that. Throughout the day, hopefully what you've managed to do is you've managed to learn about how to set up and configure your field recorder, in this case the H4n Zoom, and you've managed to be able to adjust your input levels. Right? You have to do this by listening carefully and looking at the meters as well. Hopefully you've figured out how to connect everything up and to record the narration using the different microphones. All right? The other things that you need, hopefully, that you've been able to do are to transfer the audio recordings from your field recorder to your computer or thumb drive or whatever the case may be, to be able to distinguish at least at a glance a condenser mic from a dynamic mic. And you should hopefully understand a little bit more about polar patterns and frequency response graphs, especially when choosing a microphone. So this will help you. Hopefully you'll be able to use close miking and distant miking techniques for recording. These things will come in really, really handy when you do your UT2 project. So be aware. This is very, very important for your UT2 project. Okay? And here are some resources that I've got for you. So please be adventurous on your own, self-directed. Go to these resources, look them up. Look up the resources I provided in the slides as well, and study them. It's not necessarily that I'll be on an exam, but it becomes really, really valuable for future projects, okay? So I hope this has been a good 6P. Sorry if I went on for a bit long, and I've tried to keep it as short as I can without leaving out too much. All right, thank you very much.